Hi friends, welcome to follow up. In this video, we are going to look at problem 543, diameter of a binary tree. This is a daily challenge problem, and also it's marked easy by leetcode. And however, I feel that this question is very interesting. Meanwhile, I want to share our plan at the very beginning. So we are going to do this problem, 543 and problem 1522 together. So for this part of the video, I'm going to focus on the current problem, 543. And then because of the thought of doing the two problems at the same time, I'm going to give two implementations of solutions to this problem. So the first one is to use the specific binary structure in this problem. And the second format solution is going to take into consideration of the binary tree case. And then we're going to, it will be very straightforward to address problem 1522 after this video. Meanwhile, these two videos for problem 543 and problem 1522 can be regarded as preliminary for problem 208 and problem 3045. The two problem 208 and problem 3045 are related to trial, a data structure. So trial and is also known as prefix tree. So it's essentially an inner tree. So this is actually one connection among this. Hopefully, if you can first review the solutions for these two problems here, and then it will help you do problem 208 and problem 3045. Without further ado, let's look at problem 543 here. Here we are given the root of a binary tree. We want to return the length of the diameter of the tree. So here the diameter of a binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. In other words, the longest path in this such a sense might not be passing through the whole root of the whole tree, I would say. So the length of a path between two nodes is represented by the number of edges between them. So actually, this length will be the number of nodes minus 1, right? So here we have two examples. In the second example, so there are two nodes, right? The length is 1, so this is a very special case. So in the first example, actually the diameter will be 3. So this is very special because one root is, say, 4 to 2 to 1 to 3, right? The length is 3. So actually the longest length or diameter, the path corresponding to diameter is not unique. You can also choose 5, 2, 1, 3, right? So in this problem, the constraints are the following. First, the number of nodes in the tree is in the range given by the closed interval, so with at least one node and bounded above by 10 to the power 4. And the node value is in between -100 and +100. So this part is not essential because we are only counting the number of nodes, right? So with that said, we are ready to do the first solution. Version V1. So for this part, for each node, I'm going to get two pieces of information. So I want to get, for each node, I want to get the longest left branch and the longest right branch, right? So here, because it's a binary tree, right? So at most, two branches. This is to distinguish with inner trees in general, right? So for example, here, if you have this root 1, so the longest path, down path from 1 to the leaf will be length 2, or have 3 nodes, say either 1 to 4 or 1 to 5. But if you look at the right subtree, so it will be just 1, including itself, right? So once we have this piece of information, so for each node, then we will be able to update the diameter and also in between we can write a recursive solution. So let me first write a solution, and then we actually want to digest a little bit further. So in order to be continuously update the diameter or the number of nodes, first I'm going to get the longest branch and longest red branch, and here I consider the number of nodes because it's easier to count, right? Later we just need to use the length -1. That will be very easy. So first I'm going to add a attribute for the class. That's the very easy. So let's write as set to be 0, right? So then I'm going to write a recursive hyperfunction so that I can call the function. When I call the function, we will automatically update this attribute. This way, it saves a lot of effort. So here I'm going to define a function f. So we pass a node. So here it do two things. For the node, for the root, so we get the number of nodes in the longest node. Say here is root to leaf path, right? We get the number of nodes in longest root to leaf path. So I guess for left branch and right branch, so simultaneously. To give you an idea, for example, for this 1, right? So we want to return for the node 1, say in example 1, we want to return 3 and 2, right? So because if from 1 to the leaf, either 4 or 5, you have 3 nodes, and for 1 from right, so you're going to have 2 nodes. And similarly, for the node at 2, so we're going to return, say, left have 2, right? Right have 2, 2, something. But you know, the longest path passing through 1 will be what? Will be 3 plus 1 plus 2 minus 1. That is 4. So 4 nodes. But this root corresponding to the longest length or the diameter, that is 3. Right? 3 is 4 minus 1. That is 3. So similarly, you can see the longest path passing through this root, or using this root 2 as the highest level. So this is level 0, this is level 1, this is level 2. It will be 2 plus 2 minus 1. That is 3. 3 nodes, right? So this corresponding to a diameter 3 minus 1, that is 2. In other words, for the left subtree, its diameter is 2, right? So in the sense of the current definition. So with that demonstrated, let's write the solution for write the hyperfunction. First, even though it assumed that the number of nodes is at least 1, so in the recursion we need to consider the null case, because this null case will be a stop condition, right? If not root, I would say it's a base case. So I'm going to return 0, 0, right? For sure, there's no nodes at all, so we return 0, 0. And then we are going to call this function for the left subtree. So for the left subtree, it will have a longest left branch or longest right branch. So I'm going to call it left, 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 right. It will be f root left. And for the right tree, we are going to have a left branch and a right branch. So we find the deepest one, that is right, right, right. It will be f root right. So first I want to explain a detail. So after this if block, the root will be not null. And then because of this fact, we can call root left and root right, right? So this is the legitimacy of this coding format. So once we have these two pieces of information, we can easily get, so what's the deepest path starting from the current root? It will be 1 plus the max for the left, between the left, right? The left branch of the left subtree and the right branch of the left subtree. So in other words, so we have a left that is max LL and LR, right? So we are going to plus 1, including the root node itself, right? the similarly right, it will be right, left, right, right, and +1. And then the longest path passing through the current root node, and it will be L plus R minus 1, right? So longest path with the current root as highest level, right, will be this number. So I want to do an update. Self result will be max the previous state of result, then the current length, number of nodes, right? So here what we save is the number of nodes, right? So this way, once we get this information, we can return left and right. So this is the hyperfunction. Actually, this is our bulk of effort. It's actually, or put it in another way, most of the logic is put into this function. You can regard this function f as a worker, right? The worker will update this result attribute for us, right? So now with that said, let's call this function, right, as f root. So now the root is not just a symbol because Python is passed by reference. We're passing the root instance for this this root given, and then you can write it like this directly, or you can just put something here. So anyway, just not place the row, and then we are going to return self result. So notice that what we saved actually is the number of node in passing each node, the longest path. Then we need to -1 because the length is number of nodes -1. So with this done, actually we finish the coding part for version v1. So before we write the second format, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here I want to make a comment. The comment is that, so here this update, because if I do this root, I do an update, because this is a recursive function. Actually, each time we call this f, so we are going to update the result state. So overall, once you call this function, what you get from the attribute self result will be the longest path, or more precisely, the number of nodes in the longest path across the tree. Because each time, if you traverse a node, we are going to find the root, the longest root corresponding to that node, with that node being the highest level. For example, 2. What the root I want to consider is 4 to 5, but not 4 to then up to 1, because 1 is a level higher, right? Just downwards. So this is the first solution. So here, the first this version of solution, we are using the fact that the tree is a binary tree. So because it's a binary tree, we can write like this, right? We call this f twice on left subtree and the right subtree in a recursive fashion. But in general, in the n-ary tree, we cannot do this for sure, right? Because there's maybe n branches, right? You cannot call n times like in this current format. So this is this comment also leads us to the second version of solution. So here I'm going to copy this function signature. So and then I mark this one as version v1. So here is another set comment. So if your purpose is just solving this current problem, you can actually stop here, because this first version is very specific to the current problem. So, but the second solution I'm going to present is more related to, it's more general. It meant to address also problem say 1522 n-ary tree diameter, right? So the reason is the reasoning is very trivial. The reasoning is that binary tree is a special inner tree, right? When n equals 2. So for the second solution, so what I'm going to do is the following. So v2. So the idea is that for each node, so in order to emphasize that we need to traverse all the nodes, I want to use v to represent the generic node. So we found 2 pieces of information, slightly different from the two pieces of information we have in version v1. So the 2 pieces of information is the following. First, let's call it dv, right? So dv will be the number of nodes, the number of nodes from the node from the node v, from node v to deepest leaf, right? So so here I want to say inclusive. So this number of nodes will include the node v itself, inclusive of v and for sure and the deepest leaf, right? But you know, this is just the count, but the different, so the number of paths having such number of nodes might not be unique. For example, in example 1, so if you start from root 1 and you want to find this dv, the dv will be 3, right? But you can have 2 paths, 1 to 4 and 1 to 5. So this is one piece of information. Another piece of information is p of v. So the p of v, I want to see the number of n nodes. So in the longest path, passing through node v, and v being the highest level node, right? So by this sentence, I mean, so if you look at 1, so this PV will be 1, 2, 3, 4, right? Because 1 has level 0, or if you use 1 indexing, 1 has level 1. Well, for 2, it will be 4 to 5. This number will be 3. Well, for 3, so you know, this will be 1, right? It counts itself. So this will be the information we are going to get. So, well, for the recursion relation, it's actually very easy. Let me quickly review here. Recursion relation. So basically, assume, let's see, u is root, right? So, and we have u left, the left subtree, and u right, the right subtree. Then we can do recursive call for u left and u right, right? So let's assume that we have d u left, right? So also we have p u left. So similarly, we have d u right and p u right, right? So this 4 pieces of the information we can get using this piece of information for the two for the left subtrees, for the 2 subtrees left and right. So we know that du, this is for the root. So it will be, so we want to find the deepest one. It will be 1. This counting the root u itself. And then we want to do this for d max d u left, right? D u right. But you know, this format can be easily generalized. So if you have n branches, you just need to take maximum among those n branches. So this is the one part. Then p of u, right? So then we have this this one. We want to find the, you know, from the left we want to find the longest one, and from the right we want to find the longest one. So then in this case we are going to do this: p u left, p u right, right. And then what I want to do is I want to do d u left. So this is the longest branch from the left towards the leaf. And then I want to plus d u right. So this is the deepest path from u to the right branch deepest path. And then I'm going to plus 1. So here plus 1 is plussing this one, right? For example, in this example 1, so you have 1 itself, then du left will be 2, right? Du right will be 1, then 2 plus 1 plus 1, that is 4. But then actually I take max among these two parts. So the reason is that it might be, this one and this one corresponding to a longest tree. So in such a sense, we want this interpretation is not best described. So it basically says that the number of nodes in the longest path passing through node V, and V being the highest one. But we are also considering the longest path passing the branches or the children's, right? So this recursion is also easily generalized, because if you have n branches, you just need to update this one to n branches. And this two will correspond to the two deepest one, right, in the subtree. You are going to be clear for this recursion relation in next problem, for problem 1522. But let's first finish the coding part for this one. So notice that this part of interpretation maybe not that precise, but you know the meaning. So we didn't want to write two very long annotations here. So with that said, let's first look at this. So here I can do things like this. So in this first version, I used a attribute, right? You can also use non-local variable. But let me first write this, and then I'll see how should we do this. So here I'm going to write a function. Let's call it f or traversal. It's the same, right? So here you have node. Let's call it root, and then if not root, so in this case we are going to return 0, 0 for sure. The deepest, in the deepest root to leaf node. So they have root to leaf path. It contains 0 nodes. Similarly, the path number node is be 0. And then let's get the left and the right information. So we are going to traverse root left and traverse root right. Then I just need to combine the two pieces of information in both left and the right subtree. Right. First, let me write with the. So here, let me write. Say left, right. Notice that both left and right will be a tuple. And then I'm going to write like this: n number of nodes, root to deepest leaf. It will be something like this: max left 0. So this 0 part, the first element in each one corresponding to the deepest path, and then the right 0. And then I'm going to plus 1, right? So then the number of nodes, longest path through nodes. It will be the max of, say, left 1, right 1, and also left 0 plus right 0. Plus 1. 1 is counting the current node. So here I also include this part in the left subtree and the right subtree. So this for sure. After you get you call this function, it will give you the desired result. It's very safe. So now what we want to return is these two pieces of information. So the number of nodes for deepest path, and also this number. So here. So with that done, now we are ready to call this one, because this one actually it's a little bit different from the logic here. So each time we update, but in here I include the max. Actually, it corresponds to taking this part all in the return. As long as you call the root, it will automatically take max for each part. So here, let's return this one, and then here I'm going to call this one, right? So it will be traverse root, and then we just need to return result minus 1 if result is greater than 0, else I just return 0, right? So before we make further comments, let's do a test. It passes one example. Now let's look at the generic case. It passes all the cases. So here, up to now, we finished the explaining the two versions of coding. So here I want to make another comment. Let's copy this part. So let's call it version v1 bar later. But let me first make this one version v2. Let's test this one. So here we use attribute. So we can actually just use it result and use it as a local variable. So here, before we write this one, a non-local result, because result is a integer, so it's immutable. But in order to modify that number, so in this using this function as a worker, we can use this non-local keywords, and then we just do some adjustment. So because this is the v1, v2, this is the v1, all right, and then so we can test this version. So solution has no attribute result. Yeah, we need to also adjust this one. So it will be right. Yeah, it passes all the cases. So I'm going to mark this one as v1 bar. Let's see. So here, let's also monitor this one, because the way we took this this one, right? So I'm thinking, so if we can update like in the original version, so we can do, so we can set a self result to be 0, and then we do not take maximum here. So for the longest pass through this node, I want to faithfully using this interpretation PV, the node in the longest path passing through the exact node V. So in this regard, we don't need this. Let's copy this one, and I'm going to do this. This will be nothing but this one. And then what I'm going to do is that self result will be max self result, and then this number. In other words, for each node, I just compare vest, right? And then I get this this one. But then when we call this function, I don't need to retrieve anything. So this, I just need to return self result minus 1. So let's this one is let's see v2. So now we have this this is the v1, this is the v1 bar, so this is the v2 where we change this one. Let's test this version. Solution has no no attribute result. Let's see where is the result. So I think I messed up this too. So here I guess I don't need this part here because I didn't comment this one. Here I need a self result equals 0, right? So now we have this part. So now let's check this version. Yeah, let's check generic case. Yeah, it passes. So notice that in this version, let's call it v2, and this one v2 bar. So notice the difference in the interpretation. So in this one, n nodes, longest path passing through the current node. So we do left plus right plus 1, right? So this version is, faithfully following this interpretation. But in between, we need to update, right? So because when we traverse each node, so we do a comparison. So overall result will be the diameter of the tree. So for this version v2 bar, so here I didn't do update. The reason is that when I get this attribute, actually what we get actually is the maximum. So this is the path that the longest path passing through the root. And also I considered all the, the children's, right? So for sure, this way we don't need to do this pass every time, but we do it in this line of code. But in here, we first get this information and then we update the class attribute. So this actually some slight difference. If you could actually understand this in a very clear fashion, so basically you can get almost everything for this video. So with that said, basically we finished the coding part for this example 543. And I'm going to use version v2 to solve problem 1522, the inner tree. As you can tell, right? So here we read two slightly versions or slightly different treatment for version v2. So you can use this two versions to problem 1522 in the same fashion. So without further ado, we are going to turn into problem 1522. Thank you so much for watching for the current problem. That's it.